Hey, welcome to yet another devlog. So I wanted to first share the progress I had on the Process Explorer project. Then I want to deep dive a little bit about some concepts that I am not fully grasping yet about how Zig works, and then uh, continue with the exercises, which right now I'm on an interesting exercise on the tutorial that I have, and that's visualizing the tree view in a tree-like structure, which I have never done before. Interestingly enough, yeah, it needs data structures, and yeah, it's not my strongest suit, but I'm going to give it a try. With that being said, let's first review where I am today. So, since yesterday's stream, I spent some time on the project. You can see on the first refactor that I did was quite significant. And basically, what I did was to splitting my logic into multiple files. At the end of the previous stream, I was in a state that most of the logic that I had was inside the main function, very procedural, and I was asking Claude that okay, my code is very procedural, and its answer was yeah, Zig by design is procedural, so that's no problem, but you can make it more readable and maintainable using some data structures and stuff like that, which is what I did, and I'm going to cover that at the end of this review because this PR is quite big. But yeah, I basically will show you how the code is structured across the project. One interesting feature that I learned was the feature of having a format function on the data structure. Basically, what it does, it's enabling me to have a string representation, a string print of the data structure that I have. So I don't need to format it again. It's like dunder str in Python, with the difference that it actually has a side effect that it prints the string. What it helps with is that I am able to uh, basically structure my string, format it without requiring allocator. That's a very nice feature, and the signature is quite nice. Basically, the signature that I have is I need to define a function that is publicly available, and then it should take an instance of itself as the first argument, and a writer, and the writer, here I'm using any type, but you can be more specific. It should be a pointer to std.io.writer, basically the writer that I made in the first session, and from there I can use the writer as I normally do without requiring an allocator. That was a very nice and interesting feature. Then again, I have some refactors on how I am parsing arguments. Again, this was a part of the main program. Now it's moved into a command library where I have some structures that basically makes it easier for me to parse the argument while also execute different logics that programs want. However, the main logic about choosing which process, which execute function needs to be run based on the command is still remaining in the main file, main.zip file, which I think is reasonable. Then what do I have? Yeah, there is a nice feature now that I'm able to actually, let's show it. So now, instead of just showing process infos in a bunch of new lines, I can basically zig run, zig build run. I show a very nice table here. Right. Uh, yeah, this was an interesting challenge because, as I said earlier, I was using that default print functionality on the process info, and this table representation was a bit different, right? And I was thinking, where do I need which one, and where should I prioritize what? So now my default printer, my default format function is printing individual info objects, and I can use it however I want. But there is a specific print function for with similar signature as the format function, but what it does is basically prints a row of the table or prints a header of the table. That's that. And then I extended my sort functionality. The previous version was quite simple, right? I was just comparing PIDs, and based on that, I was sending a less than feature, but I wanted it to be more flexible, so I can sort it on name, PID, and state. There was some interesting learning here that I want to continue going deeper into why this function, this design is happening here. Initial approach that I had was that I was using a helper struct function to basically decide what kind of operator needs to be used based on the order choice. But I learned that it's not possible to use parameters of parent function inside the nested helper struct function. And then I realized the first argument that initially I was setting to void can actually contain a context structure, and that's where I can actually pass in the extra detail that I need for this function to work. For example, when I am calling the process sort here, I'm passing this sort context to the function, and these values are available here. From my understanding, this is behaving like how in the functional programming world you pass in the state of your logic without storing it in an object. So every time you call a function, you have this context that you can basically manipulate. And for me, yeah, this context is variable because I need to basically update it when I'm parsing the arguments. Then what else? Yeah, I added some arguments. Now it's also able to, for example, sort based on name. Here you see the name is sorted, and then also what else? I can change the order to descending. Should be the other way around. Okay, nice. There is a bug apparently. I need to figure out why it's happening, but yeah, basically the idea is that it should also accept the order. Cool. What else? And then I have the filter functionality, which is basically now I'm able to, for example, set a state to running, and the only processes that it lists are those that are running, right? I had some interesting ideas here. So if you remember in the previous session, this there was a struct that I was using for the type of command that I'm passing in. And now that has been extended way more. Now I have a table section that basically defines the behavior of a table with all of the values set to some sensible default. And when I'm initializing it, I have this create function to initialize it without hassle to default value. When I create this table, I can set its values based on what is inside the arguments passed by the user, and I can use those values without any change inside the main function or passing a different kind of argument here. So that's that. What else I have interesting here? Yeah, the estate now has its own type, which I'm going to show you. So this is the progress so far. Let me actually go to this to do and also add one for fix sort order. Just quickly checking if it's only not working with PID. So now PID is ascending, and then if I do descending, yeah, for some reason it's not working. I will figure this out later. Now let's take a look at the structure that I have. I now have two files, process info and the command. The main is super simple now. Basically what I'm doing is I'm setting some allocators, setting the writer here in the main body of the program, right? This is the basic requirements for all the functionalities to execute. And then I have a switch statement, which is very nicer compared to previous if else do this, do that. I have a nice switch statement that based on the command type being info, tree, or table is going to call the related functions or perform the required behavior. The info one is still very simple, so I didn't extract it. I'm just keeping it here, and the tree and the table are extracted. So the first thing I want to look at is the parser command. So this is basically the command object that I have. It has quite a few types that is a function. The type that I the main type that I have is this command, which is a union enum. So basically, only one of these types can be defined, which maps to the behavior of the application. And the most complex one is the table, which is basically this struct where I can define filters. So far, as you see, I have a range filter and a state filter, and then order and sort, which are related to this function. For the state, I am using an optional custom value, process info.state, which is defined inside the process info file I'm going to show you. And then basically the parser allocator is happening here, parser logic. What I do is basically grabbing the iterator, I'm initializing it, and then I am defining a table, even though it's not always used. I'm initializing it. because I'm not sure about this state, but if needed, I need to update it inside the while loop. There are some priorities happening. So if, for example, you use info, it will automatically just parse the next argument and ignore the rest. The same for tree. But if there is min, max, and sort, and these two have not been met, it's going to try to basically update the table values. You see here it's updating the range, min, and max. And then for sort, it is basically updating the sort value, the order value, and then finally there is an state command that is defining a state filter for the table. And if none of the other returns happen, this return is going to take place and return the field in table based on the updated values. And then I have the execute table, which is basically the same logic that we implemented before, and execute table, which basically is also almost the same logic as before. I just renamed some stuff. I learned something new here. Yesterday I had this problem that I couldn't update a flag. For example, I was doing var my name and then src, and then I wanted to do my name equal to test. It was failing on compile time, and that's because, as you see here, the type is a constant pointer that I cannot change it. So apparently, according to this model, I can, let's see where I was. Mostly yours. No, this is not the question. I wanted to. Yeah, here it was. This is basically the 4 types of constant that I can define, and the idea here is I can change it if, and instead of a pointer, I have like this. This should solve the problem I had earlier. So hopefully next time I'm going to try it. This is all there is about the command, and then I have the process info. So the most interesting one is this state type that I have here. This state type has some helper functions, like from a state info that is taking the state info character and returning enum value related to the representing the state. And then there are some helper functions to, for example, print the shortcode or print the not print, return the shortcode or return the full name. And there is also a format representation, which makes it easier for me to use the state. Basically, I pass in the state into the format, and it will print out the string version, right? That's that. And then what do I have? Yeah, from stat alloc, this is also the same logic. I've just extracted it. The only change here is that state now is of type state, which is defined down here. And nothing drastically changed here. And then I have the format representation, which is, as I said, is the default presentation. Right now it's only used with info flag. And then I have print row and print header, which basically using the table representation. It can probably use more customization, but currently I don't have it. And this is the sort function I described, which relies on some other enums and structs. super simple to follow, super simple after you learn how it works. And then yeah, this is basically it. So what I wanted to dig deep into is the order function, right? Was it the order? No, I wanted to std mem sort. It's not here, it's inside the command. std mem dot sort. Yes, I want to see how this function is defined, right? As I said, it wasn't possible to yeah, easily have a dynamic logic inside the body of the function without a lot of if else statements. So this description of LLM around it is the lambda that I was using. But this is of course the Scala. In a Scala, you'd write this syntax, and there the function here has access to the x, right? The lambda captures ascending from the enclosing scope under the hood. The compiler allocates a closure object to hold that captured value. This is hidden, you don't see the allocation, you don't control its lifetime. Zig refuses to do anything hidden. A closure would mean either a stack capture or heap capture, both violate Zig's core principles. So instead, pass the state explicitly as a parameter, and this is the state, basically the context. And that's why I said it's very similar to functional programming. You reach for this pattern whenever you use a closure in other languages. That's nice. And then if I go to the sort function, I want to see if I can read it. Okay, this is the interesting part. The context is defined to be of any type. And this context, how is it invoked? So it says it's returning void, comp type. Okay, less than is a function. Type of context. LHS, right, left hand side, right hand side, boolean. This is how they are passing in the context. Oh man, I didn't expect it to be so simple. Let me write it again. I cannot do it here, but let's do it in the command. That's it. So there is a function called format, right, which returns void, and then what do I have is a type, and this type could be anything, right? Is it com type? Okay, com time t type, and then I have items, which is, what is it? Type here is a list of type. Okay, and then I have context, which is any type, and then I have less than fn, which is a function. How do we define this? Is fn, and then okay, in parentheses I get type of context, then left hand side of type t, right hand side of type t, and it returns a bool. And what is this sort block is doing? Stable in place sort O of n best case, O n log n worst case, and average case. Okay. O1 memory, no allocator required. Source in ascending order with respect to the given less than function. The algorithm only works when the comparison is less than or greater than. Very interesting. And then here it's passing in the functions that we defined. Okay. So the whole complexity in my mind is solved by generic types. That's interesting. Actually, maybe I'm thinking I need to move my screen, split it like this. This is more readable for the code. Less line breaks. Yeah. Good. Cool. So what should I do next? Let's first work on the bug we found. One more interesting thing I learned yesterday. I'm not sure if it was yesterday or other day. One of my friends showed me a program was compiling very fast for 200 megabytes, and then I got curious how much space this program is taking, and when with the default compilation flags I run the the process, it's the output is almost 10 megabytes. But if I do zig build dash d optimize release small library, oh z I know zig release small, the output is 41 kilobytes. This is really interesting. Probably a lot of the debugging information are not included in the binary, but yeah, there is upside into it. Okay. Regarding the block functionality, I learned the order should be based on less than and greater than functionality. Let's see. What am I doing here? I'm setting the order and then process info. Yeah, here. So when it's name, let's see if it's actually the build run sort PID ascending, not here, and then name. Okay. it is not, so it should do the ordering in place. It's not ordering for anything. It's not just divided name. Oh, name was there PID. For PID, it is there, but the ascending descending is not working. For name, it's also there. Okay, so the sort is happening, the order is not taking place. My idea was if it's taking less than and I reverse the result, it should reverse the order, but apparently that's not happening. Oh, this is why. It's sort order. Okay. I made a mistake in... Okay, there is no bug. It is working. So... interesting. So I can mark that off. Should cancel it because... Okay, that's that. Let's go for exercises. Exercise number 1, dynamic column width. Calculate maximum width needed for each column and adjust formatting. Okay, so where am I doing this? It's in print row. I'm not going to do it for everything because I know in the next stage the columns that I'm going to show would be different. I'm going to keep it to PID and name, expecting this is going to remain across the exercises. State and PPID 8 should be enough. Yeah, PPID no, but yeah. Okay, how should I do this? I'm now using print row, and that means I need to break the signature of my function. So can I have pop const column width of a struct? And then, for example, I have PID EU16, for example, and then name EU16, and for both of them default to 8. And I can should I require it? Or I think with this signature I don't need to worry about that. Width of column width. Right, and then here do what is the syntax? How can I nest it like this? Okay. Okay, let's see if this works. No, it shouldn't work by default, right? I think I already broke with row. This is a syntax problem. Inside print row function, I'm trying to dynamically set the column width. What is the correct syntax? And for runtime with oh, okay, this is too magical. Like this. Did I save it? Yes. Oh, okay. I made a mistake. This is where I want to put a star. The star transform and take the next argument as a width value. So your args tuple would have the width value right before or after. Check the position. This is one of the situations that you could say the compiler is already telling you this. My mistake, yeah. Doesn't use a star. It uses index or name to reference a runtime width from the args. What did it look at? RG runtime. So let's go to this. Can I LSV identifier at point not okay. How about changing this to IO Stevie IO writer? Now it's better. You probably can find it now. And print is taking comp time FMT. Oh, okay. So go back to my code. So here I can do width .pid, and then remove this. Probably not. It's already claiming that I'm not using that variable. Yeah. Should I do const with PID? No, let's go back to FMT. There is oh, okay. The width here is defined by name. Okay, so got it. We do it like it's not possible. Okay, and then I think I understand it, but now I have a conflict with the actual values I'm passing to the formatter. I should organize it. Maybe if I move it to the end, right, and 1 0 1 2 3 4. I put 4 here. Forget about this. And for example, if I put 25 here, okay, it worked, right? And I'm not really sure if I like this syntax. This is, it doesn't feel right. But I'm going to keep it as named values because index counting would be a pain. PID widths, and then I have name widths, which is with stuff name. Right, and then I can do like this, name widths. Let's make it already bigger by default. And order it like this. Yes, better. Now, if I go to, actually, I can do a trick here. I think for both PID and PPID, I can use PID widths. This is better. And then I can go to comment. Here, I want to have the maximum PID. Maximum name, and for the maximum name, I don't think there is a better way than just iterating everything. I have two options. First, if I can rely on the current state of sort order. I think I'm going to iterate anyways. For var max PID equal to processes dot items 0. Var max name processes items 0. For processes dot items process I forgot the name of the function I was using. They can also be equal. Yeah, but equal would be the same name, right? So I can say max actually should be less than. Max name should be process. And that's it. And again, if max PID is less than max EID PID that PID is less than process dot PID. This is not necessarily fast, but it's simple in terms of I don't require to be careful about what is the current order of the processes array. And then I can have const PID width equal to std mem dot count. Is for counting occurrences of a value in a slice, not what you need. For name is already okay. Oh, that was interesting. So const name width is equal to max name dot length. And for PID is either not a string, you'd need or use stdmath log10. Okay, that was interesting. stdmath log10. PID minus oh, it's not minus, it's PID plus one, like this. Are you sure that was type? Yeah, now I see you do. Okay, nice. And then const column width is equal to process info column width PID remove this. I need to have the same functionality for print header, but I can column width. Oh, max name dot name dot, yep. It was telling me that it needs a U16. Yes, that's because I set it to a U16. So if I go to process info and column width, it should be a U30. Can it guess it now? This one is the U size. Nice. Okay. Cool. And let's make sure the headers are also aligned, and then this column width I'm going to move to the top. Width, column width. Unused, yeah, you are absolutely right. So again, what I do is I call it PID equal to state equal to PPID equal to what happened? No, I didn't want you. Name equal you, then these two. And then from here I have PID width, PID width as colon name width. Beautiful. Cool. Let's compare it to the previous one. Yeah, they were shifted a little bit. Now they are starting in the same place. Review. Yeah, new feature I added. Future dynamic will be based on the actual data, name, format, argument on clean, crash on empty list. Yeah, log 10. If the max PID is 0, shouldn't happen in practice, but worth considering. Tracking the whole. That's correct. I don't need to hold struct. We can fix that like this. And then call it max name, max process, name, PID. Okay, this one is solved. Then crash an empty list. Maybe on an empty list, I can just exit even before sort, right? It just doesn't make sense. So also let's refactor this. It says U8 would be enough. Okay, and then means that I need to cast them here. Won't work, right? Should I do an int cast? I don't like this. Okay, nice. Oh, okay. Wait a minute, why I didn't do it earlier? Yeah. So max name len less than process dot name dot len. Okay, let's see what is the next. It says read full command. I am not printing the command, but I can check. Actually, I need to go to process info. For the CMD line, what am I doing? Yeah, I'm reading the full command already, but I'm not just printing them. Okay, that is done, and preview is something I'm going to preview, and the JSON output is something I'm going to do later. I really hope that I can finish it this weekend. So reach my goal. Probably I need to extend it to Saturday. But yeah, it was an interesting journey so far. I think that's it for today. Thanks for watching, and see you in the next one.